first extra, which would be our SD card data logging, as well as AEM display, of which Jerry has integrated into our system. So he can kind of touch on this.
Yeah, so building off of that, this year I spent my time working on our data logging system, as well as the display on the car. In regards for the display, it was iterating upon a device which we have previously used, that being an AEM CD5. Really just bringing, I guess, the new parameters onto this year's car. And then for the data logging system, this year we shifted away from custom data logging, and we went with something off the shelf, a new device per se, and I had a lot of fun setting up the entire data pipeline for acquiring the data, processing the data, and then plotting the data. But yeah.
The camera just died.
Yeah, so in like a race car, you're always trying to tune your systems for the highest performance. So gathering all of that data, trying to change your designs based on the data you collect, that is one of the most critical parts, I think, of this team. But other than that, we have another critical design, which is the wire harness. All those signals need to get to places around the car. They need to get there somewhere, somehow. So that is another critical design. But overall, the design philosophy for electrical this year was attempting to sort of make things more modular, make all of our devices more independent, and so that when one fails, we can still have a working system. Not everything hinges on one device or component, as well as just making it more aesthetic and clean. I can't read my other point. Oh, but yes, of course, in an electric vehicle, you have your high voltage and low voltage system. And because electrical is kind of like the brains of the car, what makes the wheels move, you need to be very mindful about your safety and your redundancy. So hopefully you'll be able to see that in our designs. So I'll start off. I have two design highlights. And I've picked out the ones that are the most intense and what I'm proud of the team that has achieved. So the first one is our custom battery management system. So we use wet cells, lithium-ion wet cells, and we need to interface with those cells and take note of all their parameters, control the discharge, the charging, and so all of that is a custom system. So we'll start off with the cell interface. We have two boards in that stack up. We have a stack up of PCBs. We have two boards. One is the battery interface board, which directly interfaces with the cell tabs. And on top of that is a battery monitoring board, which includes all this fancy cell interface, filtering, circuitry, but our main guy for that is our president, Anton Kaufman, but he can tell you more about that.
Yeah, so our battery is made up of 128, or this year 140 pouch cells in series. So each of those cells, we track its temperature and its voltage through these two boards, which are fully analog, no firmware written on them. And the chips we use for storing all this data are sponsored by Tesla. And these are actually the same chips, analog devices designed specifically for Tesla's batteries in their EVs. So it's great that we get to work with them. Yeah, and you can see, so those are 10 modules in that top right picture. Each module has 14 cells, that's how we get to 140. And then, so each of these boards has to be manufactured 10 times, and that's the most intense part of it. Unfortunately, you're not going to see this when you see the car in real life, because we don't have the battery out, one, and second, we don't open the battery if we don't have to. So, yeah, but there you can get a picture of it.
Yeah, so it's pretty complex. They're called modules. That is each little segment of cells. All those modules need to come together into the whole battery. And this is achieved by the battery management system, of which the designer is Juliana Nyberg, but this is kind of what controls it all. She can touch it.
Yeah, so as a battery management system lead, I've really enjoyed the chance to learn a lot more about the high voltage system on the car. And basically, if you're not familiar, like the role of the battery management system is just to make sure that the battery is always safe and reliable so that the car can drive without us having to worry about anything happening to our obviously a little bit volatile lithium cells. So I think my favorite part of the BMS is that it's like a lot of different, you get to learn about a lot of different things throughout the year. So I started the year designing the BMS PCB in Altium and learning about the whole high voltage system, and there's a lot of rules that pertain to the battery obviously, so learning all of the rules and making sure that our designs will comply with that. And then over winter break and kind of around then, I wrote a lot of embedded firmware to have like alert monitoring and data logging for all of our cell voltages so that we have all that data for our battery, since the battery is kind of unique because all of the things you see there, like once we seal the battery, those will be enclosed, and so we rely on data logging to get all of the parameters that we need. And then in the spring, I've spent a lot of time doing more of the manufacturing of the high voltage harness and everything else that you see, everything else you see in that compartment to make sure that our battery is safe and that when we're ready to drive the car, the battery will power the whole vehicle without any issues. Yeah, so those are our battery management system. We'll move on to our vehicle controls. So I'd like to do a comparison with last year. Last year, we were working with one inverter, one motor. This year, try 4 of each. So as you can see here, that picture with the devices, those are our inverter modules. So each contains 2 inverters. So we have a total of 4 inverters on the car, which is, well, a step up in our controls environment. So we, like last year, we have our sensing, we have our communication, we have inverter communication, inverter controls. However, this year, because we have 4 motors, we have a lot more flexibility in what we can control. This is achieved through our torque vectoring algorithm, and as well as vehicle controllers. We have faults, fault response, as well as sensing. But member of our controls, 2 members, Bhuvan and Andrew, have been very involved in that. Andrew has been working on the rear vehicle controller, which does most of the sensing and fault response. 2 of the important ones being brake system possibility device and accelerator pedal position sensor. Yeah, but he can touch on those.
Yeah, so FSAE requires us to have some safety checks to make sure that our car doesn't drive away from us, or like basically we want to make sure that what the driver tells the car to do, it does. And so one of those is the brake system's plausibility device, and that happens if you press down on the accelerator and then it gets stuck. In that case, if you press the brake, you want it to stop. So when that happens, the whole like high voltage system loses its power, so that the car doesn't drive away from you. And then the APPS is a acceleration pedal position system, and that makes sure that your acceleration pedal, it is required to have 2 sensors on it to make sure that what pedal position you have is is the pedal position measured by the control system. So then, if they get too far off, then the high voltage power cuts off, and then it's not safe. So,
Yeah. And with all the sensors and all those faults, we have our main inverter control, which is Bhuvan has been working on our torque vectoring and interface with our inertial measurement unit, but he can explain a bit more.
Sure. I'm Bhuvan. I'm from the control sub-team, and I'm working on torque vectoring, traction control, and the vehicle dynamics of the car. So you see the red thing on the bottom right, that's our inertial navigation system unit. It's from Vectornav. It's called the VN300. And it's about the size of a quarter, but it costs like $4,000. Yeah. So with 4 motors, of course you have a lot of flexibility, but you gotta make sure they're all in sync. You don't want the driver turning left and the car going right. So with the torque vectoring or the traction control algorithms, I guess the basic version of it is to simulate an open differential, where it just helps the car drive around the track. But with more advanced data from the Vectornav, we get acceleration data. It has GPS and velocity and all other stuff. And we get a lot of, we have tire models running on the controllers, like front vehicle controllers, and PI controllers also running on the front vehicle controls, which compare the target yaw rate to the car's yaw rate and correct for it with additional torque moment. So yaw moment. So this is torque vectoring. And basically the goal of this is to ensure that we get a good lap time at autocross, maybe shave a couple seconds off the lap time. So yeah, that's a goal. So pretty advanced systems that we are implementing this year.
Yeah, so that's electrical, and I guess plus side is you can wire the car for rear end or our all-wheel drive. So that's electrical. Thank you.
Thank you so much, electrical. Next up is going to be frame and body, and I'm just going to give a quick, just for all the future people presenting, let's just try to be a little concise and just make up time just for the sake of time. We'll do lots of questions answerings after this.
Hello, so every one of us is going to say a little, I'm just kidding. Hi, my name is Eduardo Sangalagi. I'm the frame and body lead, and this is a lot, but not all, of the frame and body team. I thought it'd be a great idea to show just how you could have seen from the statistic, we aren't just one person, we're a whole bunch of people. And especially with frame and body, more than many other sub-teams, we really do hit a lot of different areas. As you can see there, we have a lot of designs to cover. We go from things like the steering system, steering wheel, cockpit, and pedal box, which are commonly referred to as ergonomics or driver interface. But we also do stuff like the chassis, so the entire frame of the car, and the entire aerodynamics package. So that includes the front wing, rear wing, side pods, diffuser and floor, and as well as bodywork. Another one I didn't mention there was just simply simulation, specifically for the CFD. And yeah, pretty much we do a lot of different works. We're one of the teams that gets involved in most diverse amounts of manufacturing and design. A lot of designers get to do a lot. And yeah, and in order to be brief, I'll kind of end it at that. You can see there a lot of the different things that new members and just general members get to do in the team. And yeah, some of the specifics that we actually do. But yeah, I just wanted to highlight 2 of the biggest design changes that we've done this year. And the first one is we've changed from what we call a hybrid chassis, which was a 3/4 composite, 1/4 steel frame chassis, to a full composite chassis. And without further ado, I wanted to introduce our monocoque designer, Avery Cullen.
Yeah, this year one of our big vehicle changes was changing the concept of our chassis. There's a few ways you can do a chassis in FSE. The most simple and common would be a space frame, which is steel tubes. What we do is a full composite monocoque, so that would be carbon fiber that we lay up in-house, and our sponsors help us cure that carbon. First, our geometry of the chassis was mostly looking forward to trying to make it as simple to manufacture as possible, alleviate previous issues we've had in manufacturing, with the main goal to not just help our stiffness to help meet our goals combined with suspension, as well as provide a geometry that we can continue to iterate on for the next few years and get our mass down to a really competitive weight on our chassis. A lot of the very early year goes on with composite panel testing. We are very lucky our university has load frames that we in-house that we can pretty much access 24/7. We lay up test panels and we break them. And we use that data to come up with a chassis that meets rules and is both lightweight.
Yeah, hold on, no, go back. One thing I do want to, too much. One thing I do want to note is that, as you can see there, we only have like a 1.5 kilo decrease in weight, but I want to say that like, I still think this is a huge step. This was probably one of the most impressive and laborious design changes that we've done this year. Obviously, we've done a lot. But yeah, it just goes to show just how much improvement can be made in this design with the current design. We're not changing it. And yeah, now I just wanted to introduce the new front wing design, which was kind of due to the new monocoque design and the front wing designer, Ibrahim Jaber.
Thank you. So, a little bit of context. As Avery said, this year's monocoque was designed around being like easy to manufacture. So a lot of the like downstream design changes were kept in mind of like that simple to manufacture feature of the monocoque. So early on in the year, we basically went through all the designs and determined, hey, how much do we want to change this? What's like the scope of change? And to keep it simple, we wanted to have as many things stay similar from last year so that we can improve on the new innovations like the new monocoque. Basically like spending our resources on things that aren't more like the new monocoque because it's such a new big change for us as a team. So this year's front wing is basically like last year's, but it adapts to the new monocoque flat floor. So in previous years we had a monocoque that had a sloped front floor. This year is completely flat, so that little center portion, that center airfoil is below the monocoque, and that's why it looks like that. This year's design also, I guess every year we have an issue with the front wing where it scrapes, and we don't want it to scrape. The judges can get mad, and it also is just bad because you're damaging your front wing. So we kept that in mind and designed the front wing around that. What else is on the slide? I don't know. I kind of got told to do this like 2 minutes ago. Yeah. And then I guess this year's numbers are better than last year's. So we got 4.8 efficiency. Yeah, that's the front wing.
Yeah, I don't have any closing thoughts. I want to keep it brief. Yeah, there was a lot of learning done this year, and it was a really fun time to get to do it with so many people that were so eager to actually try new things and, again, learn, which is what we're here to do in the first place. So, yeah, thank you.
I think for the sake of time, we're going to skip over the operations overview. I think that okay, how about, that's a good point. Let's have the operations members come on stage. We got to recognize you. I think we're going to skip all the talking. And then Zachariah is at the back. He won't be able to come on because he's running the live stream right now. Sweet. So, operations this year has been quite different than previous years. Just give the general thing of like, last year this was branded as business, and we decided to I came in and decided to rebrand the team to operations and kind of change a lot of the scope to cover a lot more areas, a lot more logistical stuff with Gopher Motorsports rather than like just the business presentation to give. So just to give an overview of my members, starting from the right, we have Tenzin, who worked on some reformatting of our presentations. We have Esley, who has done a number of things around event planning and for helping planning this event and a lot of awesome stuff. Charlie has been super involved all year with generally leading our business presentation, doing a bunch of different tasks, working on a newsletter, all those things. We had Ellie, who is also responsible for helping out with this event, other events that we've been doing, getting an article in the SAE Momentum magazine about our custom motor system, and also doing the last newsletter. We have Noah, who has been, the team has been working very hard on team documentary all year, and Noah and I have been kind of like the primary, well, Noah's been primarily leading most of it. I'm so glad that he's stepped up and taken a lot of responsibility over that. We have Joseph, who has helped with a lot of different tasks, including some sponsorship preparement, and Shane, who's worked on helping prepare our livery ahead of time of the competition, as well as helping with some event planning. So yeah, thank you. If you wouldn't mind just giving my operations team a round of applause. Next up will be powertrain.
Alright, I'm just gathering the troops here to see who we're on this. There's two more right there. I guess, well, those two are coming up. I'm Dallas Buckwitz. I'm the powertrain sub-team lead this year. But yeah, they're close here. Alright. So basically, this year has been a big architecture change from going from one motor rear-wheel drive to four-wheel drive, four-motor system, which then has its own consequences with gearboxes, and then and we can kind of talk more about that later. But wow, it has been a year. People talk about being an officer is challenging, but holy cow, it has been a journey and a half. But these guys are what makes it happen, not me. I'm just the head guy, but. Like it has been amazing to watch all the progress that has been made with all the challenges we have been through design of all these complex systems that stepping into foreign territory that we don't have any documentation on, and it is super tough to gauge on just how to design these complex systems and just understand the limitations of them. And it has been through iterative EDR processes, which is our engineering design reviews. And I just want to have a huge thanks to all of our alumni that have helped out a bunch with that, because honestly, I think a lot of our major steps in our design changes wouldn't have been made without them. So let's just give them a quick round of applause. I know as I'm graduating in the fall, I will definitely come back for EDRs because it is such a cool experience to be able to, one, reminisce about FCA, and then two, also be able to get feedback from industry people that have been in our shoes and have understood what limitations we have. But so just kind of get a nitty gritty, just kind of overview. Kind of our big changes this year. One thing is going to 140 cell tractive battery. So last year we were at, I think 480 volts. I can't remember what the peak voltage was last year, but this year we're able to go to 599.2. Which is due to our open space in the monocoque now. We could actually be able to fit 140 cells in there physically. We have custom motors, and honestly we can talk about that in a little bit. So basically here's kind of the specs on them, and they have been a huge step that I think has been a good foundation for years to come. So, and then along with that we have our planetary gearbox, which Idris will talk about more. And then also our cooling loop change due to all of our architecture changes. But it has been an awesome year, and these guys deserve way more credit than I do. They are the dream team. It has been awesome. Every week is awesome. I love it with these guys. So we'll just kind of go through our two main design highlights, and then yeah. So first we'll start off with Idris and Gearbox.
Hello everyone, my name is Idris. I am the lead designer for the gearbox. The purpose of the system is to increase the torque from the motor by a factor of 12.8. And I think the main challenge when making the system has been actually manufacturing the gears, because basically we had to wire EDM them with our sponsor, Woodland Tool, then harden them with another sponsor called Nitrix, and surface finish them by another sponsor called REM, and then that just involves moving gears across the country, and just like to thank all of our sponsors for supporting us and bringing this gearbox to life.
Okay, so the next design is the motors, which has been one of our biggest changes for this year. We have 4 motors one in each wheel. It's been a really challenging project because we've never done anything like this before. So we've had to learn like what sponsors we need to reach out to. We've had a lot of people that have given us a lot of help, especially with machining that we can't necessarily do in-house. You can see the specs if you're interested in them on the screen, but yeah, those are the motors.
Yeah, so just kind of wrap up. Honestly, I think the biggest, I would agree with I think all of us would agree, the hardest thing this year has been manufacturing. It has just been an extreme challenge to make these super complex parts with very limited access to resources. So I, again, really want to thank sponsors for helping us out, because without you guys, we wouldn't be able to do anything. So, or we would be very limited, I should say. So, again, I really appreciate it. So this is Powertrain, guys. So.
Hi all, I'm Jason. I'm the suspension lead for this year, so we're just going to be having everyone who's worked on the suspension this year. There are a few people who couldn't make it, but this is the team we have so far. Just to put into context, probably over the past couple days, everyone here has probably put in, at least 20, 30 hours like this week, and just imagine that throughout each person, imagine that throughout the entire year. So anything that's on the car, or unfortunately not on the car, you can ask them about. These guys have done, a bunch of design work, simulation work, machining, assembly to get the product that you'll see in just a bit. So if you have any questions, you can ask them, but we'll get into basically what is suspension. So it goes over 4 different designs. Kinematics, which is the vehicle dynamics, how the car behaves when you give it different scenarios. Inboard, outboard suspension, which is your uprights and your wheel centers, basically anything that's not directly attached to the chassis. Your inboard suspension, so that's your dampers, your springs, spherical capture sphericals, basically anything that's attached to the car, to the chassis itself. And then your brakes, which I hope you all know what brakes are.
No, we drive race cars.
Yeah, so we mainly focus on design, simulation, manufacturing, and then testing and validation work. How we can improve. It's all a question of, how can we make less mass? How can we make this product stiffer, stronger? How can we make it easier to machine? Going into that, one of, I guess I'll go into the first major design is the kinematics. For the past couple of years, we've kept the same main chassis, which has limited our ability in creating different kinematics. They're basically the imaginary points that you put all your spherical bearings that dictate how the car moves when it goes over a bump or when you turn it at a certain amount. Basically, so one of the main features that we've changed is an upper push rod, which was for clearance with the in-hub motors. Let's see what else I wrote. We lowered the wheelbase from 1585 millimeters to 1530 millimeters. Increased our anti-geometry. Basically, when you brake or accelerate, your car pitches. We just lowered that response. We wanted to control our roll center a bit more. Last year and previous years it was a bit finicky, so just wanted to get a better understanding. The main thing though that I want out of this design is proper, like really good documentation so that people in the future can understand how to design kinematic, what the kinematics design really is, what it's asking for, and what it means to make a quote-unquote good one. So next steps, for instance, we want to validate our system, understand like what forces are going through our linkages, like what's going on at our tire and contact patch, which really helps for designing and simulating a lot of our components. Like for instance, our other really big component that's had a lot of changes is our upright. So this is like one of those components I was talking about in the outboard assembly. This year, one of like some of the like high-end vehicle goals was to have an in-hub motor and outboard gearbox, so we needed an upright that would interface with that. Here you can see like just some general pictures of what the upright looks like. It looks a lot cooler in person, I swear. There, right? So yeah, some basic, I have like a general overview of like what the upright is for those of you who like might not be super familiar with it. But some key changes is that since we're gonna have that motor in there, we need like cooling ports, we need that large bore, which was usually just for a bearing or for like a drive shaft to go into, to now fit a motor. And then we also need like that planetary gearbox integration, so that's like that kind of weird looking back section where it's like all like flanged and curved and stuff. So yeah, just like, I have some general structure stuff that's not super important, but I believe now, I'm gonna move this on the next slide, I'm not sure what it is, but we get to awards. Alex wants to continue from that, but I guess as just a final thing, everyone here has put in a lot of really hard work, and I personally really like talking about my design. Maybe I really hope they do too, so if you have any questions about anything, please feel free to ask. Yeah, thank you all.
Right. Let's pull up the list here. So we're gonna run through some awards. These are just ways to recognize. In some ways, the majority of the awards are more, fun ones than actually quantitative ones. With so many engineers working so hard, it's really hard to recognize some as standing out way ahead of the rest. Everybody's just putting in so much work, but we thought it'd be fun to just put in some awards just to recognize people for different fun things that have happened during the year that you guys get to learn about. So, and then the awards, it's gonna be these monster cans that we got over here. I'm gonna hand them. It's much more for recognition than for getting something physical, but let me grab the first one. The first award we're starting off is Rookie of the Year. So this is, team members voted who is the favorite new member. If you were to choose one, who had maybe had brought the most smiles or had the most fun as a first year. And the winner of this award goes to Charlie Webb. Come on up. So this one's especially fun because I had to remove an award for Charlie. Charlie also would have.
Let me guess. As soon as I saw the award, I said, "Oh no, I'm gonna get this other one too." The other award was Sim Hog, who's always on the racing sim. I'm the biggest bum on the team. I never did any work. I was always just racing. That's a joke. But I did want to say 30 seconds. I just want to say something because I was really inspired by this team. I'm only a freshman and I came into the university wanting to do as much as I could, and I'm also a business major, right? So I did basically nothing for homework. I think I had an Excel class. I think they had a coloring class too or something like that, but I never really paid attention. So I had a lot of time, and I saw this big car outside of Superblock, what we call the 4 dorms, and it was Avery and Julia, and they were there, and I said, "What's this?" And they said, "Well, it's a race car, and here's some cool things about it." And I said, I want to drive. That's what everybody says. And they said, "Well, you can't just drive, you have to actually be on the team." So I joined the team because I wanted to drive. And I also knew how to weld, and I wanted to weld, and they said, "Well, we're actually going to a full carbon fiber frame, so there's no welding anymore." So I said, "Well, man, just kick me out already." But I ended up joining business because I am a business major, and when I was on the sim, being a bum all the time, driving, as part of our driver program, I saw a lot of really passionate people working in the shop all the time. And I would go in at like 2 p.m. To the electrical workspace and say, hi, how you doing? I'd leave and I'd come back at 2 a.m. and they'd still be there. And I'd say, oh my gosh, go home. But it's the people like that who really showed me how much this team can mean to people. And the friends I've made are truly irreplaceable. I don't know what I would do with myself if I didn't join this club. And so I just want to say thank you to everyone on this team for not pushing me away, for being inviting, and electing me for project manager for next year. I feel like this year has been one of the best years of my life, and it's because of the opportunities these people and this team gave me. Thank you.
Great. Thank you, Charlie. I will say speeches are optional for the next thing. I would say try not to take more than 60 seconds because we still have a nice video we want to show you, but let's move on to the next one. All right, so this one's a little bit of an inside joke. This is the Office Unlock Attempt award, and the reason for this is because the card reader on the team's office mechanical engineering is very finicky and tends to not unlock very often. So we chose one person that, from what we felt like, had the most attempts at unlocking the door every single time before they go in. Because you can hear every single time somebody's trying. It'll beep, it'll beep, it'll beep, and then they won't get in. So we're going to give an award for this one. And the award winner for this award is Tyler Engen. All right, sorry if I said the last name. So you can choose whether you're happy to win this award or not, but you can at least claim your monster. The front here.
Do you have anything to say? Thank you.
All right, moving on. All right, we'll try to make our time back. Caffeinated award. So generally we're in college. Caffeine is not something that's uncommon in our workspaces. In fact, we pulled open a whole pack of Monster yesterday to make sure we got the whole car done. So the winner of this award, who always seemed the most caffeinated, was Enric. He knew he was winning this award. You giving the speech, Enric, or no?
I think it speaks for itself.
Okay. So, this award is the biggest slacker award, and the context behind it is not the negative who is slacking during the team. It was because we used the communication program Slack, and this was for whoever sent the most messages. And I'm just going to jump quickly to this one because the winner is myself. It's not Rick. So I'll take this one. No speeches needed. Just sometimes my Slack messages would be like 6 paragraphs long, and I didn't apologize for making them long. I just felt it was important to communicate. So that's what happened. All right. So the next award is the Sponsor Whisperer Award. So this is, we obviously need a lot of sponsorships to make this team work, but some people are better at acquiring those sponsorships than others, and the team nominated Carson for this award. Oh, Carson is not here, unfortunately, but Carson Ashberger, I think that's how you pronounce the last name, has won the Sponsor Whisperer Award. Right, I think we only got a couple more. High Spender. It's the same monster. High Spender. So this award is for whoever was perceived to have spent the most of the team's money single-handedly, putting in the purchase orders for the team to buy things. And the winner of this award is Soren Bielefeld.
I'll get it later.
He'll get his monster afterwards. I'll keep this monster this time. The next one is the best mentor/mentee pairing. So there's a lot of new people that come in. There's a lot of people to be mentored. And the best pairing was nominated to be Irene Oscarson and Avi. I don't quite remember last name. just give them a second to come on down. You got Abby coming from over there. You can have my monster. How about that? You can have, both of you can have monsters. There you go. Sweet. You got a speech? Nope. Sounds good. We'll keep moving on. All right. I think we got one more. Yep. And this last award is the Team Culture Award. So this one was one that was suggested by somebody and not voted on. But I liked it so much that I wanted to make sure that we gave it out. Do we have any more monsters? I think, yeah, we got one. So the winner of this award is Eduardo. All right, without further ado, we have a little bit of further ado. We want to thank our sponsors. These are our diamond sponsors. Especially thank them. They've contributed the most to making this team run every single year. If you want to see the rest of them, go at our website, Gopher-Motorsports.com. It has every single sponsor as of yesterday. And then I just want to do a little bit of a shout out and a plug for sponsors/donations. Obviously, we've talked so much about how sponsors make this team happen. And I just wanted to point, if you are potentially interested in sponsoring the team or requesting somebody from your company to potentially take a look at sponsoring our team, we'd love to give you information about that. I guess I don't have the email here, but sae.umn.edu is our email, sae@umn.edu. We'd love to contact you to talk about any potential sponsorship opportunities. We're always looking for all opportunities because we're always trying to build better cars and need more sponsorships in order to make those happen, especially the financial ones. It's hard to get enough money to buy the things that we need. So just highlight that we promise our sponsors different tiers depending on how much they provide us in either services or monetary donations, and then we provide different benefits to them, the best of our ability that we can. As we also have put all our sponsors on our vehicle. And then finally, donations. We have a donations page through the UMN Foundation giving page. Always appreciate any donations to the team because every dollar helps improve our team. If you saw from the breakdown of the financial thing, donations made up over 10% of our money this year, which is more than previous years. And again, we barely we're a little bit in the red from this year, so we'd be even more so there if we didn't have all your wonderful donations. So thank you so much. And then without further ado, we'll get to the nice video that we have prepared right before we unveil the vehicle.
And what did this team mean to you personally?
Yeah, I mean, this team has been a lot of my time for the past 4 years. It's been great. There's a ton of amazing people on the team. There's a lot of support. A lot of my friends are on the team. And it makes me excited to come back every single day.
Because the last time we've done it was like 5-6 years ago, something like that.
Funny enough, it's not like an electrical thing. The second monocoque, I think second or third monocoque last year, that last monocoque, just staying up late, working on it, not going to class, and just like having fun, making the car, watching it, like in that time, things are really accelerated. You get to see like the car you spent all year designing, like finally, like in front of you, in front of your eyes.
to find their passion in engineering and find out if it's what they want to do.
Rougher ending, but yeah. So now is the part where we unveil the vehicle. And one of the things we would have loved to do, and what we were planning to the entire time, was to have the vehicle up on stage for you. But one of those things that we ran into as we were doing this is we thought that we would be able to use the freight elevator that goes down here to move the vehicle down to this location. And when we opened up the freight elevator, we realized the freight elevator is not as wide as the vehicle, which meant that it was completely impossible for us to get the vehicle down. One thing I wanted to say is, like, you didn't see me, after 5:30 this started, I sprinted all the way back to Meki in my dress shoes to try to get a screwdriver to see if we could take out the post of the door, but we were not able to get the vehicle down here. So I hope it's one of the things we ran into. However, the vehicle is still here, and we'd love to show it to you, but we are going to have to go out the door, and we're going to have to go up the escalators into the main area of Kaufman in order to view it. So that is what we're going to have to do in order to take a look, but we'd love all of you to come. We'd love all of you to ask so many amazing questions, and we cannot wait to pull the blanket off and show you the entire vehicle.
Just note the consequences to your.
I know, but I'm hungry. I haven't eaten.
To be clear, I think you should have one. I also think your stomach's gonna.
I don't know. Wait. Oh, sorry.
Hello. How are you? Tired.
Oh, wait, sorry. I'm gonna. You're texting me about the sub-team.
Oh yeah. Yeah. Tell us. I was just asking Maddie what you were texting her. I was texting her. Yeah.
Their field trip.
But all the anticipation,
Anticipation. Oh, really? High point of anticipation.
No.
She worked at the
All right, ask away.
I got it in the middle of the countdown.
Sure.
Yeah.
Do you want to put it on the tripod?
Yes.
We can put it on the table potentially. Yep. We might have lost connection for a second.
I guess it's.
Uh-oh, battery pack's dead.
Yeah, this is the second battery.
Well, there's not much we can do then.
Yeah.
Can you use your laptop again?
Yeah, that'd be a little janky, but yeah, sure.
Maybe let's just end the live
I could do my phone camera.
That work? Oh no. Let's change options somehow. If you have your phone camera, I think that's the best.
Yeah, I guess so.
Then you can go around the vehicle or something.
So Alex.
Hello.
How's it going?
It's
been crazy, I'm sure.
It's been really very, very crazy. I am surprised that it's turned out this well, honestly. But
That's a lot of fun story because I know you guys work together on this anyway.
Yeah.
How close is actually
actually driving?
Yeah.
We're looking at somewhere between a week and a half.
That's not bad.
Yeah,
That's
it's
not
not
bad
bad.
at all.
And it's especially not bad from working with that in the past. Yes, exactly. So,
As you, I mean, you've seen it, right?
Yeah,
So
I've seen it.
you've been through it. You know,
Exactly.
especially last year. That was special.
Yes. And I'm not familiar. What's your name?
Oh, Michael. I'm from there.
Oh, I see. Okay.
Hence,
I see.
The obnoxious shirt.
Nice. Yeah. Yep. It's been a lot.
Yeah. I mean, you and I live in the same house.
Yep.
Right. But I haven't seen you a few times. Oh, don't worry about that.
Yeah.
I think I met your parents once. The time I was there.
Oh, nice.
Yeah, but that's
Stand up for
like
the
right
chair.
after dinner or something.
Sure. Yeah.
Are you staying there all summer, or are you also
Yeah,
going out?
it's good.
In Texas.
Congratulations.
Yeah, thank you.
What company are you going to?
Exactly. Sit up on a chair.
Oh, okay.
Kind of my dream job.
Fantastic.
Very happy with it.
So before or after competition?
Before competition, but I'm coming back.
Okay. Oh wow. Yeah, sorry to busy. I'm about. I've asked them, where different people who are. So let's say only 4 people in the team are graduating this year. That be that slide line?
It's gotta be more.
It's gotta be more, right? Maybe I mean because this has number of years on the team and number of 4 years.
That people always join the team that first year.
True.
A lot of people actually don't. So
Okay.
that's the overall reason for that. Yep.
This is
Hello. How are you?
He doesn't know.
Yep. Thank you so much. Yeah, it's been a lot. It has been a lot. Yeah.
We're moving to Oh my goodness.
I'll be able to hold it.
For you too. How do you? Here, this is your teammate. You can get in here.
I know, but there's no real space for
Did you want to go around that way?
That's awesome.
Are there people on the thing? Are people online?
I can't check because I'm on my phone.
I think you should get a picture of the car.